So we're going to talk about strike and dip here, and we're looking at a pretend outcrop. So I've taken some of my landscape rocks here and created a tilted layer of rock. So when we're looking to determine whether we have different types of folds or what happened in an area, usually related to tectonics, mountain building and things like that, we want to know whether which direction they're tilted and how they're oriented in space. So if we imagine that this is a tilted layer, we want to know how much is it tilted. If it started out horizontally, is it tilted this way or this way? But we also want to know is how it's oriented in space in 360 degrees. So the way to do that is we need to know the compass direction of the rock as it is for the strike of it. So we think of strike as the intersection between a tilted layer. Daisy, get over here. My helper. Sit. Sit. Okay. So, no. So we want to know how much this is tilted. We have to know where it's tilted. So we imagine that this was horizontal, and at some point it crosses the horizontal plane. That line, where if we have an imaginary layer that's the plane parallel to the surface or to the original direction, the intersection between the horizontal and the tilted layer, that is strike. So I would lay my compass here. I don't have my compasses from campus because I didn't think to bring it, and I would lie the edge of it right on the strike, and then I would read the compass direction. In this case, it says it's 167 degrees. So that means from north all the way around 167 degrees, that line that connects 167 degrees to its complement, whatever 360 minus 167 is, that would be the line that I would draw. Now dip is the angle that the layer makes with the horizontal. So we want to know how much it's tilted. So it was horizontal when it was laid down. Now it's tilted at this angle. We want to know what angle that is. So to find dip, sometimes dip is always 90 degrees to strike. Sometimes in this layer it's pretty easy. Dip is down this direction. But if that rock is, kind of wonky or something, it might be difficult to tell, or it might be hard to find strike. Where exactly is strike? So we always know that strike is 90 degrees to dip, and dip is 90 degrees from strike. So if I put a drop of water here, it's always going to run straight downhill. So this is the dip direction, which means strike, I didn't measure it totally correctly. Strike is like this. It's actually 158, not 167 as I originally thought. But then we would measure the angle here of dip from the horizontal down to the rock. Now this compass doesn't have a little angle, a clinometer where I can measure it, but we have compasses that do have that. The ones in campus do, and you can also get a clinometer for your phone as well. A lot of people use their phones now because they're convenient, and you can actually do strike and dip straight with your phone. So that's strike and dip. Strike is the intersection between the angled layer and the horizontal. Dip is that angle that we see, the amount of tilting that is experienced by the bed. And that's strike and dip.